So what do you do when you have way too many of one type of hard drive laying around? Well, you start playing around with RAID arrays. And so that's what we're going to be doing now. So these are the drives I have for testing today. These are 1 terabyte WD, I think AV drives. They're 5400 RPM. They're green power. I don't know if they do all the very heavy parking of the heads like the WD greens do, the old ones. Now they're rebranded as blues. Or they just operate more normally like the old blues do. But they're designed to be more lower power. They're pretty quiet. I think they're 5400 RPM drives. I have a ton of them now. I have more than 10 now. So we're going to be playing around with them a little bit and trying different RAID arrays and see what's the fastest. So this is our test bench today. We got a 8350, has 6 SATA 6 ports running off the chipset. We also have an LSI RAID card we're going to play with in a little bit that we can mess with around a bit. Now this does support RAID on the AMD chipset with SATA 6 gigabit, but I personally really hate RAID on the OS because it's almost always pretty bad when you do RAID in the hardware. Now we're going to also mess with different software RAID configurations and stuff a bit. For testing OS-wise, we're going to be using Ubuntu 17.10 with all the latest updates. We're going to be using FIO just for comparative numbers. We're going to be doing sequential read, sequential write, and probably what's more important than that is IOPS, which is random data. We're just doing random transactions. We're going to be doing IOPS of half read, half write, see how quickly we can do it. And I'm going to be trying with a few. So the first thing I'm going to do is just a single one of these drives, and then we're going to start adding bigger and bigger arrays of different types. So I was going to use this RAID card here to do RAID of 4 more drives to give me a total of 6 drives, but unfortunately I have 2 of them, neither of them work. Both of them have firmware issues. One won't turn it on at all, the other will turn on but just have issues and doesn't show up its drives correctly. So I'm going to do one more thing and then show all the exciting and boring graphs and data, and that's going to be try to install it on a RAID for Windows. Linux supports easy booting on software RAID, so you don't need hardware or fake RAID support on your motherboard. Windows doesn't, and they've basically stuck in with you gotta use NTFS, a single NTFS volume for boot, basically since, I think XP, at least Vista. So we're gonna go set all of these to RAID mode, exit, then you mash F10 when you're booting, you make a big array, and there you go. We're going to try that and see how the performance in Windows is. Now, we're looking at the IOPS, and a little spoiler alert, actually IOPS scale fairly well with multiple drives. Now, but it's still a lot slower than an SSD. So here's a quick look. We got RAID mode, RAID 0. We're going to use RAID 0 here for the fastest speed. Stripe block. This is the how big each stripe on each drive are before going to the next stripe. Generally, bigger stripes are better for sequential, smaller stripes are better for random, and if you know exactly what size of data, get it close to that. Initialization, fast or slow. Fast just tells it, writes a little bit in the beginning. Slow will go 0 the whole drive. Fast is fine. Gigabyte boundary makes it so it's slightly smaller, so you can replace it with a drive that's slightly smaller. So you see these are 1000.2 gigabytes. I could replace it with a 1000 gig drive, because not all drives that say 1000 gigs are exactly 1000 gigs. Sector size, how big the physical sectors are. 512 has best compatibility. New stuff should work perfectly fine in 4K though. Read policy, read ahead caching. This will read the drive whenever you're reading data and read it from the cache. And stack caching makes it so it writes it to the cache first and then puts it on the drives, instead of putting on the drives and then telling it the OS is done. Turn these all to Y. Now then we can hit Control Y to save. Hit it again. We're going to call it RAID 0. Hit enter, Control Y again, and it'll erase all the data on the drive. Control Y, any other key, we're going to just use the default capacity. See 6 terabytes of data, and that's pretty much it. And hit escape to exit, Y to reboot, and then we're going to select the Windows installer and just shove Windows 10 on here. One thing to note, since it is 6 terabytes, you do need to use UEFI if you want to use the whole drive. Otherwise, you're limited in MBR to 2 terabytes of data. So that's what we're going to be using here. And Windows 7 and above supports UEFI. And I think it's booting from my flash drive right now. I think that's the only drive that could have Windows on it. And here we can see the 5.5 TB storage space is equivalent to 6 terabytes due to 1024 versus 1000 counting of data. We're going to hit next, and it's going to install it in UEFI mode and be done in like 10 minutes. So here it is installed on the system. Well, apparently without my knowledge, it installed via MBR instead of UEFI, so I only have 2 terabytes usable here. You can see the drive. It's not doing very much right now. All of its basic setup stuff is done. Windows is doing a bit. Superfetch is caching a bit more, so you can see it's caching this. So yeah, you only have like less than a gig of free memory because it's all cached. Now if I run like Crystal Disk Mark right now, it should be getting 600 if it's working correctly. I don't know how good AMD's RAID thingy is. I know it is running on CPU though, and it needs actually the AMD drivers and stuff to work, and doesn't work correctly. There we go. There's the first number. That's a bit worse than we're getting in with Linux software RAID, but it's fine. And you can see it's only touching 1 core. Actually, it's only touching the first core, which something tells me is due to the implementation, because normally it wants to touch more cores than that. Sequential speeds, random speeds aren't bad for a mechanical at all, and we can definitely see there's some caching giving us the 7s here because they should be a bit slower and closer to this because read-write speeds on these hard drives are almost identical. One more test. We're going to do a reboot speed. Rebooting in Windows is different than shutting it down and turning it back off because it forces it to turn off Quick Boot, which Quick Boot will basically copy an image like hibernation instead of loading all the services individually. Opening Task Manager, not too bad. And then we're going to wait for the disk usage to drop down to 0, and then we're going to do one more quick test. So now disk usage has dropped, so we're going to do one more test, which is just opening Edge. How long it is so we get a usable page. A bit slower than an SSD, but not horrible. I don't know how much caching it's done yet, though. Hasn't cached too much. So now I'm going to test this and compare it to a single hard drive, and then I'm going to look at the Linux data results for just all the FIO tests. So Crystal Disk Mark is done, and we see, yeah, much slower speeds. Actually, random speeds are quite a bit smaller for 4K random writes and reads, which is more surprising to me. And now we're going to do the next test, which is just the reboot test again. I'm probably just going to count the time to be only from the time when it started booting after it posted, because the RAID adds quite a bit of time to the post just because the RAID controller has to initialize. And then here comes the Edge test. The RAID seems a bit faster, but really, and noticeably, like boot times and stuff, it's not that much. Just the benchmark numbers and self and stuff say they're pointing quite a bit bigger numbers, but really, real life performance seems to be fairly similar. This is Windows 10 on a hard drive. It feels like Windows 10 on a hard drive. Everything just takes a little bit of time. I mean, all these little programs they have, I don't know if this is installed. Oh, it's installed. It's just gonna take some time to open and uses the drive. So let's look at the Linux benchmark numbers now.
So let's take a look at all the different data we've got first. So this first graph is comparing the speed differences as we add drives to RAID 0 and Btrfs. I reset the file system every time, so there wasn't any sort of caching or anything between them. And going from single drive on the left to 6 drives on the right, with blue bars being sequential reads in megabytes per second, red bars being sequential writes in megabytes per second, the tall yellow ones being the read IOPS, and the green ones being write IOPS, and this is true for all the graphs. We see it basically goes up every single time. The amount it goes up by is different. Some of this may be due to testing methodology and stuff, but I ran it a few times on the ones that seemed questionable, and it mostly catched up. You notice we get a reasonable jump to 2 drives, pretty much about what we'd expect, not 100%, but fairly close. 3 drives are almost there. 4 drives is a very small change, actually. We do get unless you look at sequential read, everything else is pretty small. 5 drives is a very large jump, and 6 drives is another small jump, except for sequential read speed. Could be due to how they're slivering out the data, or something else. Now the next graph we're looking at between RAID levels of 6 drives. So on the left we have RAID 0, which is definitely the fastest. In the middle we have RAID 6, and then on the right we have RAID 10. And you can see RAID 10 basically lives up to what most people say it is, which is better for random IOPS. as we see the IOPS, so a good amount better than RAID 6, but actually sequential is worse. And that's probably just due to how it can only read from 3 drives from once, whereas RAID 6 can read from 4 drives from once, and RAID 0 can read from 6 drives at once on here. I don't know why the write speeds are slow on RAID 0 and RAID 10, and if we look at the old graph again, we notice the writes are quite a bit worse with larger RAID arrays in Btrfs. Now, that could just be a Btrfs problem, so I ran MD RAID, and here's MD RAID with 0, 5, 6, and 10. And we noticed that 10, for whatever reason, I reran this, had a horrible performance. 6 and 5 both had basically what you'd expect for parity writes, which is a good amount slower IOPS compared to RAID 0, and much slower writes, actually quite slow, at less than 200 megabytes a second for 6 drives, which is quite bad. And RAID 0 performed pretty much what you expect, basically the fastest. Now this was running MD with Btrfs on top of it as a file system. I did test all the file systems, so Btrfs, Btrfs, exe4, and XFS. And Btrfs was the fastest of all 3 on a single drive, so I decided to use Btrfs for everything. So here's RAID 0 versus Btrfs versus MD. We notice Btrfs has slightly faster sequential reads, everything else is a bit slower compared to MD. RAID 6, the random IOPS are significantly worse. Write speeds though on Btrfs is much better than MD though, don't know why. And RAID 10 we get significantly better performance in Btrfs on both sides, especially the random IOPS though. And just to put this in perspective, that's an Intel SSD, an older SATA SSD. You notice the sequential speeds, which are quite small, are not really that good, especially the sequential writes on that SSD aren't great. They normally do get a bit worse with age. But those random IOPS are insane on SSDs. The max I could get was about 1.6 thousand IOPS with the current test on MD with RAID 0 of 6 drives, where I got over 20,000 on that SSD. New SSDs I think can get over 100,000. And here's all the data together. So that's a quick look at the different data with the RAID levels. Nothing really that interesting. A lot of this is probably just due to how exactly the RAID implementation works. And as you can tell, not everything works out as good as you'd say on paper. I might try this in the future with like a hardware RAID controller instead, or maybe using Windows as RAID instead. But that's what the look of Linux RAID is. I didn't try ZFS this time, I had a few issues with it. But thanks for watching, subscribe for more data testing and other benchmark videos in the future.